Hi, today we've been talking about water and some of its many properties. Now, to start off with, first we have the water's polarity. Now, what is polarity? Polarity is a molecule's distribution of electrons, which is uneven, which results in one side having a partial positive charge and another side having a partial negative charge. Now, to find out the polarity of water, first you need to know if it has a covalent or ionic bond. Now, in this case, water has a covalent bond, which means that the oxygen and hydrogens share electrons. However, oxygen is an extremely electronegative atom. Now, what is electronegativity? Electronegativity is just an atom's ability to attract electrons. So if the oxygen is extremely electronegative, it attracts electrons a lot more than these hydrogens do. Because of that, it pulls the bonded electrons closer to the oxygen than it is to the hydrogen. This results in the hydrogen getting a partial positive charge and the oxygen getting a partial negative charge. So what does this mean? Well, because of this polarity, this gives water many other properties as well, because it allows for hydrogen bonding. Now, why is that important? Well, let's move on to the cohesion property of water. Because of water's property of its polarity and its uneven charges, this allows it to form hydrogen bonds. These bonds form because the oxygens are electronegative and they have a partial negative charge compared to hydrogen's partial positive charge. So since positive and negative attract, they can create weak attractions, or strong attractions in this case, with each other, which result in what are known as hydrogen bonds. These hydrogen bonds give water what you can commonly know as surface tension. Surface tension, fun fact, if water didn't have a surface tension, if you dropped like a single drop of water, instead of it just sitting there waiting for you to clean it up, the water would actually spread across your entire household in an evenly distributed layer. So if you spill a drop, instead of just having a drop, you'd have like a thin layer across your entire house of water. And that'd be much more annoying to clean up than just a drop on the ground. Now, since cohesion is the water's ability to stick with itself, the other form is adhesion, which is basically water's ability to stick to other things. Now, one example where this occurs would be the xylem in a plant. The xylem allows for the water to stick to it, so the cohesion property can pull water up as water evaporates on a plant's leaves. So if you have a plant here and leaves here, there's water on the leaves that evaporate in the sun, and when it evaporates, the water sticks to itself and pulls itself up the plant from the roots. However, as it does this, it sticks to the xylem. Since without it, there'd be nothing for the water to stick to, and it'd be impossible for it to get pulled up all of this stem through the roots here. So since the water adheres to the xylem, it allows it to cohere all the way up the plant, which allows the plant to distribute water wherever it needs it. This is known as capillary action. Now, moving on, let's go to some of the physical properties of water. The first one we'll look at is known as buoyancy. It's something's ability to float. Not to be confused with surface tension. Buoyancy is different because instead of relying on just being extremely light, or so light you don't break the surface tension, it relies on surface area and density to float. For example, whereas like a small fly or mosquito or a paperclip can sit on top of water despite being denser than water, that would be surface tension holding it up instead of buoyancy. However, let's say you have like a cruise ship. That thing is a lot denser than water and yet it still floats. That is due to its buoyancy and its density. Now, the second one is viscosity. Viscosity is the thickness of the fluid, or how well it flows. An example of a more viscous fluid than water would be something like, I don't know, mucus or cake batter. Cake batter is a lot thicker than water is. You can see because of the way it oozes out when you pour it. And something less viscous than water would be something like alcohol. Now, another important property is thermal conductivity. What that means is that water conducts heat pretty well. That's close enough. Now, because of the thermal conductivity, that means heat passes through water relatively quickly. So if I take like 100 degrees Celsius spoon and I dunk it in some water, well, first there'll be some steam, but the spoon will cool down pretty quickly compared to if I just left it in the open air. That's what the thermal conductivity of water is about. It wicks heat away from the spoon or a really hot object really fast. Now, the fourth property is heat capacity or thermal capacity, which kind of ties in with this one here, in the sense that it takes a lot of heat to break the hydrogen bonds in water and make it evaporate into a gas. So in this case, in the example up here, it definitely would be enough since it's really hot, and it'll just start steaming. All of it won't evaporate, but definitely some of it will. Let's say it was 100 degrees Celsius though, or Fahrenheit. Now that might not be hot enough or quite hot enough to make the water start steaming like up here, but it would still definitely cool down. But the fact that it's not steaming and it's staying together, that's the heat capacity of water, and that's what that's all about. Now, some other properties that water has, partially due to its polarity, are hydrophilic substances. Since water is a universal solvent, there are a ton of things that water can dissolve, which are mostly polar molecules. And hydrophobic, on the other hand, are mostly nonpolar molecules. Now, an example of a hydrophilic or water-loving would be something like salt or sugar. That's a bag of sugar, by the way. Whereas something that's hydrophobic would be some kind of fat, like oil or lipid. Now, how does this affect like everything in general, or what is water? How does it come to be? Well, talking about water in our on Earth, for water to exist on a planet, it needs to be within what's known as the Goldilocks zone, which in a solar system, be it ours or any other, it's an area in the solar system where it's not too hot and not too cold. That's a snowflake. And it's an area between that's just right. Now, Earth is in the Goldilocks zone for our solar system, and there's dozens of others across the universe. In this zone, it's not too hot, where water will just evaporate instantly, and it's not too cold, where it'll just remain frozen. I got the symbols mixed up too. The flame is supposed to be right there, and the ice right here. It's not going to be too cold right next to the star of the system. An example of a really cold planet would be something like Neptune. Neptune is extremely cold, and it's mostly ice, whereas Mercury is far too hot. Now, how does water even get to our planet in the first place? Well, common theory suggests that as the Earth was forming, when it was just a big hunk of rock, a bunch of asteroids came in that were made of ice. And as the planet heated up, the ice melted, and that gave us our oceans and our water. Since once the planet first formed, it'd be much too hot to have water in the first place, and since we didn't have an atmosphere, any water that was originally present would have evaporated away into the universe. Well, that's a quick crash course on some of the properties of water. I hope you learned something. Thank you.